So hey guys, so this video is going to be a really short video, but I want you guys to listen to this video till the very end, because we are going to study about something that has been really clicking the minds of a lot of people who are not in the AI world, that the LLM architecture is going to achieve AGI. And this paper is a bit old. It was released on 1st of February 2024, but believe me, this paper is more than enough to tell a lot of people that benchmarks are not the best way to test a model, and let you know that okay, this model is that much good, and to tell you that what are language models actually learning. So yeah, this is a pretty interesting paper. I have been waiting for a very long time to make a video on this, so I think we can start. Cool. So the paper name itself is When Benchmarks Are Targets, revealing the sensitivity of large language model leaderboard. Now, if you read some important lines of it, they are saying under existing leaderboards, the relative performance of LLMs is highly sensitive. Often, minute details. We show that for popular MMLU like benchmarks, minor tweaks to the benchmark, such as changing the order of choices or method of the answer selection, result in rankings up to 8 position. Yes, this is true, up to 8 positions. Now let's take a very short example so that this video won't become very long. In this thing, what they have done, they were passing this to the model and expecting an answer, right? So this was the default style. You are giving it a question, the answer, like the options, and then you get an answer, right? This is the correct answer that you have in the backend. Just imagine these are all the models, these were the rankings. Keep this in your mind. Now they have, instead of using these symbols, they have used these symbols, the rare symbols, and the answer is obviously going to remain same. If it was Riyadh that time, it is going to say Riyadh, but obviously the symbol is going to be this, right? Now the difference is so much. This why 6 billion fell from third place to, I don't know, seventh place. Just imagine that. And not only this, 5-2 fell from sixth place, I think sixth rank, to the second last rank. Just imagine the difference. And let's, the fixed answer is B. We are making sure that the answer is B here, right? Is always B. So in that case, just imagine, in that case, these top models remain same, but Llama 2 70 billion comes on from second to third, and this what do you say, Mistral model remains one position down. The Phi model from the fifth position comes to a second last again. And similarly for other models, you are going to see a very vast difference sometimes, and I don't want to talk about this because same things are happening here. So the point is, what are our language models learning? I know you guys have the answer that okay, obviously they are predicting the next word, right? But the point is that people who are talking about AGI coming into play using LLM, is that true? No, obviously not. And the whole point is, our models are not learning the information or not understanding the information, they are just learning the patterns. The whole point is that through this paper, they definitely say they are learning the patterns through words, that how are they connected and everything, attention, we know, right? So that's the thing. That is why when you see these kind of things happening, you question yourself, are we moving in the right direction? Or we are definitely moving in the right direction, but obviously we are a very long way from AGI, I would say. We need something new. And yeah, so let's look at one more thing. What they did is, they did three things. They answer choicing, format, and ordering. Okay, cool. So their first thing is they change the choice order, right? They random choice order there. Our first study aims to uncover how dependent MCQ benchmarks performs and rankings on the original ordering of the choices, right? So they do simple two things: swapping choices using a fixed set of source for all questions, and randomly assigning new position to each choice while ensuring each choice is moved to a different position. Cool. This was one thing they did. Then next they did is, they made a bias, for example, right? For they are providing at least 5 shots, let's say they are providing 5 shots and all of them have answer fixed to A. Now then they are passing it to original question, right? There are two cases in this thing, right? The answer is C, is not A, or the is A. So we want to see if there is a bias when we are passing 5 shots to a model and then ask it to generate an answer. Will it always say A? That's the question. Is there a bias in that? Similarly, they did for evaluation, they did symbol scoring, hybrid scoring, close scoring. So that I want you guys to go and read from the paper. It's really good. Now, if you look at the results, it's really astonishing, right? So change in accuracy and bias, this change in bias, just think this as the change in bias. It's calculated using this way. On zero shot MMLU, after swapping answer choices with two different set of models of symbols, you will see a vast difference, right? The accuracy change is fast. Just imagine this was set 1 and this is set 2. This is like, obviously you're going to get, this is a very small difference, right? But just imagine, these we are testing on a very small set, right? Just imagine on like real life questions and examples, there is obviously going to be a vast difference. Similarly, we show that model rankings can shift under the shuffling of the order of answers. Now just see, just by shuffling the orders, we can see that 5 to remain same. Why 6 billion comes from 3 to 9, Mistral 7 billion 4 to 3, 8 to 8, 11 to 11 remains same, Llama to 7 billion chat 9 to 10, and 5 to 4 70 billion chat. So the point is, even after training the data on the model on so much data, and I personally think some of these people are using the benchmarking data itself as the training data. It's pretty clear sometimes, right? When you see this much difference, right? What is this? So when you see this much difference, it's pretty clear that you have trained, you at least use some of the benchmarking data, right? So that's the case. Now the accuracy and the bias change after randomly shuffling the order of the choices along their options IDs. Same thing you will see here, shuffling choices alongside the content. Now if you see here, using a set of rare symbols, they say, and same thing you see here, there's a symbol. Now the symbols and the choices, the difference is pretty clear here. Similarly, performance on zero shot MMLU when placing the correct answer at each possible position. All the LLM tested show clear preference for specific position answer choice symbol. This is what is happening, guys, at the back end, right? Let me show you one more thing, one last thing, and let that be this. Yes. So the result of fixing the 5 short few examples answers to position ABCD on one model from each family averaged over 3 selected subjects, right? So we can definitely see a drop, a performance drop across all case models, right? We are passing, let's say A, so there is a definitely decrease in the rest of them, right? Because we are being biased towards a particular option. So yeah, I don't want to keep this video very long, because this was I wanted to keep this video very short. But the whole point of this paper is that no, we are not reaching AGI with the current structure of LLM, definitely not. And the point is, what are our models learning? Are they learning something? Which a lot of people say after Claude 3.5 and Claude 3 came, the needle in the haystack solution was passed. People were saying, okay, we have the models are understanding words and everything. No, it's not. It's just basic mathematics we all know at the back end, right? And it should be pretty clear that the models can be blackmailed or sort of by passing it a set of examples and tweaking the results. So that's the thing. We can definitely outperform the benchmarks. We can make sure that a model doesn't get the correct answer by passing a set of prompts, and we can also make sure that a model gets a correct answer by passing a set of prompts, right? So these much tweaking can be done, and we see a clear difference, right? The position changes dramatically from rank 3 to rank 9. It's a very big shift, right? So yeah, that was the purpose of this video. I will pin down this research paper in the description as usual. I want you guys to go and read and just enjoy this research paper, as it is full of information. Go and do check the appendix. They are giving you everything that is in the paper with the examples and the prompts. So thank you and have a nice day.